Hey guys, good morning. Thank you for attending this session. This is third session in the series of five. So in last two session, Abhishek has discussed about web analytics, how to capture data using web analytics tools like Google and Adobe Analytics. Then we started discussing about Python and the Jupyter Notebook. So we are now moving into phase where we have started capturing the data. We have understood the tools that we are going to use to analyze the data. So now, Abhishek, over to you. Please help us understand how to analyze the data using Python and the Jupyter Notebook.
Sure, sure, Ashish, thanks. Good afternoon, good evening, and good morning, everyone. As usual, we are back again this Saturday with a session on Jupyter Notebook and how to analyze data on Jupyter Notebook using Python. So, since last few weeks, like last couple of weeks, we were talking about how to capture the data, how to gather the data, which was using through Google Analytics or using Adobe Analytics. And we were talking mostly about web analytics data, web analysis, web data, I would say. So web data or data from CRM or data from sales from the field, it doesn't matter. Data is data. You can analyze it using any tool, whatever product you're using, whatever tool you are using in your company. One of the really popular tool, as I was talking last week also, is Jupyter Notebook in among the data scientist community, and you will see tons of video, tons of I would say help available out there if you just search session on Jupyter Notebook or session on Python. So you will get tons of resources. So there is no limitation in resources, to be honest. So feel free to use any resource, LinkedIn Learning resource, Google Stack Overflow resources, or any blogs which you find on medium.com. So feel free to use any of those. The idea of this session is to make you familiarize with some of the common functions which we use in Python to clean the data. Several programmers have like every programmers have their own style of writing codes, their own way of thinking how to clean the data. So suppose I use one function, it might possible that somebody will use different function or maybe use different approach to basically do the same data cleaning work. So as I mentioned, like it depends on how experience. Sometimes it depends on experience. So suppose you are starting, so probably you will just Google and start working on the basic functions, and that is a good start. But as you improve on experience, as you start working on data analysis, and you start doing things like very rapidly, very often in your work, then you will start thinking about different approach. You start thinking about approach which is quick, fast, and easy to remember. So that's the approach we basically take in data cleaning, and data cleaning is really important in our um, analysis work. So let me share my screen. So can you make me present, Ashish?
Yeah, sure. Yeah, here you go.
Okay, all right. Thanks, guys. So hold on a second. All right. Can you see my screen now?
Yes, we can.
Okay. So, so before we start on our any function or anything on Jupyter Notebook, I would like to check with audience here if they have any questions, and and if they got stuck in last week's session. Okay, so no question. Great. So we all know that we are going to use data, which I shared last week, COVID-19 data from WHO. We will use that data for data cleaning work, and to show which method you can use very frequently. And we'll do data exploration using using the common like libraries available for plotting the graph. For example, Matplotlib, or for example, Seaborn. So we'll use these libraries to plot some graphs, but very basic, not very advanced. But we will do at some advanced session also as we progress in the sessions, because we are going to work on predictions, we are going to work on classification in future. All right. So in our last session, we talked about importing the data. How do we import? And as I mentioned, there is a inbuilt method in pandas. Like Panda is one of the libraries which we use for a lot of like I would say for data import and a lot of other activities we use in Python. So Panda is very common libraries, is being used by data scientist people. So there are so many methods over there. You can use pd.read underscore CSV file to read your CSV file inside your Python UI, like the Jupyter Notebook UI, and then you can start work on it. We will take a quick look. And so this is what I will make sure that we cover everything, and we'll start working on some of the operations which we're going to do today. So I do not have a lot of slides, but we will be working on hands-on exercise. So if you guys are working together with me, make sure that you have the Jupyter Notebook, the local host running, and then what you can do, you can click on new and you can start with Python 3 notebook. So, and we can start together. So let's give session 3 demo, right? Great. So we will first try to import the data. So first, before we import the data, before we get the data, we will start importing the library. So I am not going to write a lot. So what I'm going to do, I'm just going to type this and I will run this. So this will import the libraries in my Jupyter Notebook. The Panda libraries basically will help us to import the CSV file, and NumPy library usually used for a lot of linear expressions, linear algebra work. So for example, like sum, if we are planning to find the mean, or we are planning to use pivot table, or pivot table is basically in Panda. So we will use mostly NumPy as a kind of a linear algebra expressions. So let's start. So this was the code. I think I'm using the last week code what I was using. So we'll get this COVID-19 data here, and then what we are going to do, we are going to do few things. I am going to show you guys like how we can look at the data and what we can like come up with it. Like, so for example, if I look at the COVID-19, if you just type COVID-19, it will show you the data frame here, and you see how the data looks like. As you see here, there are so many countries where the number of cases cumulative total is 0, as you see here. So and it might be possible that we don't need these countries in our data analysis. So if a country is having cumulative death total 0 and cumulative cases 0, then probably it's better to remove that country, isn't it? Make sense?
Yes.
Okay, sure. How we do that? That's a very simple question. So what we do here is we are going to filter the data. We will going to filter data with all the countries where the cumulative debt total and cases cumulative total is not zero. So we are going to write a simple command here. So let's start with COVID 19. Uh, sorry, COVID 19, and how we'll access this. So we'll start typing this, and this is one of the way to access the column. So we'll use this approach. It's a very standard approach in. Give me 1 second. So now we'll copy the column name. Okay. And we'll have all the column, remove that rows. All right, so let's run this, see what happens. See, it gives invalid syntax because we have missed the bracket here. So, okay, great. So now we basically removed all the rows where we had zero. How we validate it? Let's just take a look. We'll use tail method, which will gives us the countries which are at the bottom. So as we see, we have removed everything from the bottom. So it's not a trick or anything. It just you are accessing the column through this approach, and you are adding a logic if not equal to zero. If these two columns value is not equal to zero, then do not add in a data frame. And as simple as that. Now this is simple. Now let's look at our data frame again. Let's see what are other issues we have find. Can someone tell me what all issues you can see? Uh, is it okay if you guys can just step up and let's be a little bit more interactive? Can you tell me like what do you the problem you see in the data? Anybody?
Non-value maybe in the whole region. WHO non-value. This one,
Yeah.
yeah, yeah.
Yes, it's a NaN value. And what else? Okay. Okay. So we see NaN value here. That's one of the challenge. And we see a lot of other zeros also. Correct. So let's see if there are some null values in the data frame. So the mostly common things you will find in data frame is that you will have NA. NA is like not available. So for example, if you are looking at data frame from e-commerce website like Amazon, it might be possible that not everybody has ordered a similar product. So if we are going to analyze that, then that data might have like NA available, that product might not be purchased with that customer. So usually data frame will have NA, which is like very common thing. So what we do to do that, we try to either replace NA by something meaningful, like either we do it by zero, or if we have to make sure that our data are not skewed a lot left or right, then what we do, we basically take a mean or median of that particular column. So for example, if we are looking at order amount of a certain user, and if order amount for that certain user is showing NA, then what we basically do to compensate that value is we will try to look for the number of orders of that person for a certain number of weeks or days, and we'll take an average or maybe median of it, and we basically replace it by that NA. So that is one of the approach to basically clean the data. You can have multiple approach. It depends on how you're planning to clean or the data or replace the data. So what we are going to do, we are going to try to find out if there is a null in the data. So let's see if there are any null values in the data. To check null value, it's is null function is there in the Python, and you can it's inbuilt function. It will tell you whether it's a null or not. So as you see here, it will tell you NaN. As somebody pointed out that there is a NaN under the WHO region column, and similarly there is a NaN under transmission classification column. So as you see here, the NaN is there only in the first row, but we do not see all the data frame here. So how we will get to know that whether any other column has NaN or not? So what we do basically, we'll try to find out through dot sum. So when we use dot sum, it gives you about list of all the columns wherever there is a NaN.
So Abhishek, here true means that it's a null value.
It's
False means it's not a null value.
yes, you're
Okay.
right. Yeah. So now, as you see, there is a NaN on 3 columns: WHO region. There is NaN one there, and then there is a NaN here in this column, and there is a NaN in this column, and there is an NaN transmission column. So there are 4 columns where there are NaN. So either you replace NaN by any value, or either you replace with anything. So it depends on how you're trying to manipulate or change the data. Make sense? Okay. Okay. All right. So now here in the data frame, data is very simple. So we'll try to remove 1 or 2 columns. Like we will try to understand how you basically remove the columns from the data. So let's look back the data again. We'll try to remove some of the columns like death cumulative total per 1 million population. So I have copied that column name, and how we are going to use it. We are going to use a method which basically help us to get rid of this column. And the method called drop. So it's a very common method. It's a method which is used to drop a column, very heavily used by user like data scientists to basically remove unnecessary data from your data exploration. So how we use, simply drop, and then you will give the name of the column under the code, and you just pass. So now that column has been dropped. How we get to know? As we see here, that column is not there. All right. So this is also a very basic, I would say, exercise in the beginning of the data cleaning work. Now, as you see, this whole header, you see, it's very clunky and it's too big. For me, it's like, why would we have like this much lengthy name of my column? It's like cases cumulative death. It's too lengthy name. Cases cumulative total per 1 million population is too lengthy name. So and it's also very difficult to access those. Let's try to show you how it is really useful to have a column name which is short. So let's see this and what value it returns. So when we do COVID_19.name, it gives us the list of all the names of the countries. What if we basically do this to WHO region? See what it gives, and see how we can make that error go away. So let's see. Run this. It gives error region. Why? Because there is a space here. So Python usually have this problem that if you define any variable, so for example, if you define something like this, car name is equal to Abhishek, let's see what happens. It gives syntax error because it doesn't expect any space in the variable. Okay, so if I define something like this, then it will accept this. So this variable will be fine. So this is one of the reason why sometimes we basically focus on deleting, or not deleting, I would say renaming the column name. So renaming the column name is really helpful to accessing the data of the column, and it basically makes us makes our life very easy, I would say. So let's try to rename one of the column. Any suggestion here on renaming the column? Any of you guys have done that before?
No, but you can use a short form of cumulative, maybe CUMM if possible.
Okay, yeah, we'll similarly use this, something like that. So let's do this. Let's try to rename two column. We'll try to rename cumulative total as a cases, and this guy we will remove it. We will rename it to total death. So let's do that. So we'll start with our COVID-19. We'll try to change the existing data frame. We will not create a new data frame. So what happens, you can store a result of renaming. So for example, if you are trying to rename a column, whatever result which comes from this command, you can store in a new data frame also. But we are not going to create a new data frame. We will use the existing data frame to get the result. So these syntax are very straightforward. You will get the syntax, like I will share this file to you guys so that you can practice. So no need to worry about it. All right, so let me just hit the run, and it looks like the rename has happened. Okay. So as you see, the cases has come over here at the top. Similarly, we will try to change it to death so that it becomes easy for us. And now, remember we were trying to access the WHO region. Let's rename that WHO region. And I'll show you how it matters. So now we are going to access the region like this. It's a very simple approach, and this will give us the region list. It's very easy to access now when you have this one word column name. So try to approach. These are the very simple thing. As a initial stage, sometimes you will struggle, but when you have these things in your mind, you will do the data cleaning work like within a few minutes, I would say. So that's the approach. Any question here? Any other data cleaning task you guys can suggest which we want to perform? Okay, no problem. So now, remember there was NaN. What we can do, we can try to replace the NaN with some data, right? We can try to fill it with the median. We can try to fill it with the mean. We can try to even fill it with zero also. That way, it doesn't look like NaN, because NaN, it is definitely not a good thing for data. So let's focus on other aspects here. The other important activity which you do in data cleaning is filtering. We try to access the column here through this approach. Remember, through this approach, we will try to filter the data, and we'll try to copy in a different data frame. So for example, if you have, let's take an example of a data collected from Amazon. Okay, you have a huge pile of data, and you would like to create a new data frame only for the country where the country name is India. In that way, because most of the time, it might be possible that one data scientist will focus on India, one data scientist might be focusing on United States in doing the analysis and providing the exploration work. So it is very often that you will be creating a new data frame by filtering the data from the existing data frame, which might be the huge data frame for you. So let's try to filter some data, and we'll filter the data based on the transmission classification. We will like to know how many countries had classification, like transmission classification, based on the cluster of cases. That's the value we are going to look at. We don't want to talk about community transmission yet. We'll look at only the cluster of cases. How we filter it. So let's try to create a new data frame, COVID-19 clusters country, clusters cases. Because you might be focused on analyzing the data in the countries where the COVID-19 has spread only to the cluster cases, not any community transmission cases. All right. So we will use this approach, COVID-19. And I think I'm using the same filtering approach, which I have used earlier. So nothing new, but there's a different in the syntax. Please take care of, look at it and look it carefully. Okay, so let me copy this. So now we are going to look for the value here. If we are filtering on categorical value, we can give equal. If we are filtering on numerical value, we can give greater than, less than, whatever. We can filter it through, like if we would like to have the country where death is more than 10,000, then we can use the death column name here, and then we can have a sign greater than equal to 10,000, which will give us all the country which has the death greater than 10,000. So depending on what kind of column you are looking at, so you can use the value here and the equality sign. So this is a simple command. So let's run this. And now if you look at this data, it will give you only rows in which the community like transmission classification value was clusters of cases. Okay, as you see, and you can do a count, like how many 45 countries were there. 45 countries were there where transmission classification was cluster of cases. Now, this is one way to understand and one way to filter. I remember
I have in purple here. I can't
sorry?
see. What is that thing in purple? Is it equal to sign twice?
Yeah, it's equal sign. Yes.
Okay. Thank you.
Yeah. So now you see here that you have the new data frame, which has all the values. Okay. Let's move forward, and I want to show you one method which I always use in my work. So one of the common method I use here is group by approach. So group by is a very common approach. So if you have a categorical column, so the column which is like having categorical values like this, where these are like mostly the numerical columns. These are also categorical columns, region and name and WHO region, and this column. Primarily, you can call it as a categorical columns, and these are the mostly numerical columns. So if you have a categorical column, you can group by the values of the numerical columns based on the category. How we do that? Let's try to understand. Let's try to categorize everything based on the transmission classification. We want to know how many cases has happened, how many death has happened due to the community transmission. We want to know how many cumulative cases has happened based on the community transmission and based on the clusters of cases. And because we want to know like whether which transmission classification is very bad for the countries and how many countries are being affected. So group Y is really easy to do that. Instead of you write a function like a for loop and go through each row, and you basically create an array to pass the value. That might take too much time to write some code. So how we do that? Let's just try to write something like this. Okay, so let's start with the basic data frame. COVID-19 dot, we'll use group Y. Group Y is one of the function, and then we'll use transmission classification. We'll group by transmission classification. Okay. And then what we are going to do after grouping these things, we are going to aggregate things. We are going to aggregate the data based on the transmission classification. So we'll use AGG method function. And in this function, we will pass the argument like on what variable we are going to aggregate this data. So this aggregate function takes the n number of columns as an argument. So you can pass multiple columns also. You can pass one column also, right? So it totally depends on you how you are going to aggregate your data based on the group Y approach. Okay, so let's start with the death number. So we are going to group by our thing by deaths. Remember, we changed the death column name, so we are just calling it as death. And this basically grouping attribute, like grouping or aggregation, will happens based on either you do the summation, either you just count the number, you can do whatever you want to do. So how you provide that data? So let me provide a sum of all the death and the count of the countries. Okay, so let's see. Okay, so looking good. We'll close this. Okay, this is good. So now let's run this, see if there's an error. Okay, column deaths does not exist. So what happened? Did we? Okay, so let's just take a look. So yeah, this is common. You get an error. Did we not change our death to something else? Oh, we changed it to W or region. Okay, I see. Let me change it back to the. I remember. I thought we did. I was about to did, but I didn't. Okay, no worries. We'll use this column. Here we can use this column name. That's not a problem. So now it works fine. Okay. So let's look at the number here, this string. So as you see here, the classification, transmission classification, number of cases, community transmission, all these things, like total number of death based on community transmission is really high, and clusters of cases is not very high. There are 137 countries where community transmission has happened, and there are only 45 countries where the cluster of cases has happened, and sporadic cases very few, and pending is still. So yeah, there are only 2 countries where there were no cases based on any community transmission. So this is a very easy way to understand. You can do the similar thing through pivot table. Pivot table is also one of the function available for you in Panda. It totally depends on you. You can just Google a pivot table. How to use pivot table? You should be able to use a pivot table in your approach. Any questions here? Because we are going to move on to a little bit of graph. So before we wrap this up, I want to check if guys have any questions in data cleaning and data cleaning approach. So few things you might be worried about, like how we can sort the data. So there are methods which comes like you can sort. Suppose, for example, you want to sort the data frame by by the death, number of death, or maybe number of this column. You can just use this function sort underscore values. So you can use this method. This method is simply you just pass the value, like by which column you would like to sort the values, and then you can provide you want to sort it through ascending order or descending order. So just pass this value, ascending or descending, true or false. Sorry, you don't need comma when you have a Boolean. So yeah, so you can use your data frame here, like your data frame dot sort. So this is very simple. So that way you should be able to sort your any column. And the reason why sorting we would like to do, because we want to see the top 10 values sometime in our data, right? We want to see our top 10 customers. So how do we do that? Top 10 customers, give me the top 10 customers by order amount. That is one of the reason why you sorting a lot. Give me the total number of like the rows which has my top visitors on the site. So you can use these approach in sorting. Yeah, Assis, any questions?
So Musharraf, do you have any question? He had a question in the chat, but you explained that, so I haven't replied. Musharraf, was that answered or you still have any doubt? Okay, he is fine.
Okay.
Sorry, I'm sorry I'm joining only today, and I don't want to drag you people back, but I'm just wondering whether this Jupyter you are calling Panda, whether Jupyter and Panda are the same, or is a feature in Jupyter.
Yeah, so Jupyter Notebook is a editor. Don't get confused here. Jupyter Notebook is just an editor. And on Jupyter Notebook, you can write programs using Python and R. Okay, and Pandas is a library name written for Python programming.
Okay.
Okay, so
you imported from a library to work
yeah,
on.
yeah. So Pandas is the name of the library which we use in our Python program. It has nothing to do with the Jupyter.
Okay.
Yeah.
Hey, this is Sarosh here. I have a quick question. In real life, I mean, this is a very good example, but in real life applications, when you have data coming in from one data source and you're trying to clean that data up and then move it into a different source, do you use this kind of a technique of using Python to clean up, or do you clean up the data at the data source and then just inject it into some kind of a data warehouse?
Yes, that's a good question. So what you do, you will write a script, you will write a function. So using these methods, so what I used here, drop, you will write a function, a very generic function. And that generic function will take an intake of a file, like a CSV file. So what I'm going to do, I will write every line, what I just said in a function, said data clean, okay? And I will pass the parameter like file name. That would be my parameter, and I will write all the functions in the function. And then this function will be uploaded on a cloud. And when you are going to use this function, you need to pass the file as a parameter, and all the results will be stored. So this is a function you have to return something. So what you are going to return, you have to return another file. So you have to return another file, and that file will have all your clean data. So that is the approach usually we take on a cloud or when your data is huge, like in GVs. This is a
Yeah,
very
so
simple approach.
let me chime in. So we do have to take similar approach, but not necessarily we have to write these codes again and again. Since the database column names, they remain same all the time. Writing
Yeah,
such cleanup script can be a one-time task. You write the cleanup script one time only, but each time you pull up the data for the clean analysis purpose, you will always find that the analyst or the data scientist clean up the data first and then only process it for further analysis, because each time data will keep on flowing into database on each day on day-to-day basis. That means every day unclean data is added to your database. So whenever you want to process it, analyze it, you should go ahead and clean the data. And in even in the like real life, we do use Jupyter Notebook and Python to clean up the
yeah,
data.
exactly. Yeah, yeah, right. Yeah, we use Python, like Jupyter Notebook, very often in data cleaning, by the way. And most of the cloud product you use, if you use Google, the cloud product, you will use IBM. They have some of the cloud products. They have inbuilt Jupyter Notebook, so you can run the Jupyter Notebook on the cloud.
Okay,
And if you
got it.
don't if you don't want to do further analysis in Jupyter Notebook, you can just export the clean data out in CSV format and upload that to any other BI tool you are using.
Yeah, and there are a spider also. I'm not sure. So Jupyter Notebook is not the only uh, editor you use. There are other editors also which you can use. I think there is Spider which you can use for Python programming. So you can write your Python program over there to data clean everything. So it's up to you what you want to choose. But the approach will remain same. You will use a similar approach, like the steps what I was mentioning. Like look at the data, you will try to figure it out what are different issues in the data, and then you execute a set of a command, and then you will get the real data which you're going to analyze, or you're going to explore it with the graphs and everything. Does it answer your question?
Oh yeah, definitely. That was really great. Thank you.
Okay, great, awesome. So any questions before we move to our graph exploration? Okay, cool. So what we are going to talk about here is for a few minutes, we'll talk about how we basically do the data exploration work in Python. So it's really important for us. So these graphs might be looking very simple for you, but when you do the data analysis, uh, uh, and you do some sort of data cleaning and you come up with a graph which might be meaningful for the business, then you will understand the meaning of like how important it is. These data is very simple. You will not see a huge difference, so but in professional world we do see a very great use of um, these functions and the methods. The good part is that why these functions and methods become really popular, because you can run these on the cloud. You can run these in the cloud, and you can build your applications. These are very flexible methods. These are not just like these are the methods which are not like Excel, where you can just draw the graph. It's totally different. You're using programs, so you are running these programs or methods on the cloud, and you can return the value in form of graph to your customer when you're building an application. That's why it is becoming so popular these days, where when you are build of your own product, your analytics product on top of these methods. All right, so let's move forward and see what happens. So now we have the libraries. We have only two libraries. So as I mentioned, we will use the inbuilt libraries in Python. So what are the two most popular libraries which basically data scientists use in exploration of data are matplotlib, and seaborn. These are the very common library you should be learning about when you start working on data exploration. So what we are going to do, we are going to look at the import seaborn as, let's do it through SNS. It's very common. So what I'm writing here is very common among the data science community. So PD is very common for pandas, NP is common for NumPy, SNS is very common for Seaborn. So what you can do, you can give your own your name also. It doesn't matter. So you have to use the same name when you are going to access this method from your library. Okay. So we are going to use matplotlib dot. So most of the plot is there in the pyplot in matplotlib. So I am going to use matplotlib.pyplot. You can use matplot also. It's not a problem. So these are the two libraries I have imported. So I'm going to run this command. Okay, so I run this. So now the import has happened. So now let's go back here. Now I'm asking to you guys, tell me what would be the most important graph you would want to see out of this, and see how whether you were able to draw that graph or not. Would you want to see the death by countries in a bar plot? Will it make sense? Because one of the common thing basically we look for while doing the data exploration is whether the graph will make sense or not. The visualization has to make sense. I mean, when you draw the visualization, you think about your axis, you think about data, you think about the scaling of the data. Like we want to make sure that the graph does not look bad. The graph should be easily understandable. All those things we have to consider that. So any suggestion on the graph? Should I go ahead and start work on the cumulative death by countries? Okay, let me try to do that. So this is our graph. So let's start with a simple plot. So how we are going to do that? We are going to do the plot through the graph. So we are going to do a bar plot, which is like the bar you see. The x-axis will contain the country's name, and the y-axis will have the cumulative death numbers. So so any graph you can. So this is the library for the matplotlib. So plt was our argument to access any of the function inside. So we'll use plt dot bar, which is the function to create a bar plot, and the function will basically take the arguments. Two arguments basically it takes one argument for your x-axis and another argument for the y-axis, and then you can have other customizations inside. So let's start with COVID-19. Let's take countries as a dot name, and then we'll have COVID-19 underscore. We'll use death. I think we should have converted death, but it's okay. It's not required as of now because you're not doing a lot of heavy lifting here. So this is one approach, and then you can provide any color. Suppose you want to give color to green, you can give green color. So now this is the graph. And now let's see what happens when we hit this. What happens? So did we miss anything? Oops, we missed the spelling of the green. Okay, so feel free to point me out. So see what happens. So this is the graph. Do you think this graph would be helpful for anybody to look at it? Absolutely not, correct?
No, not at all.
You can't figure it out what is in this graph. So there is no, this is what I want to show to you. Like you cannot just plot any graph when you are doing data exploration. You need to think about what you're plotting and how it will look. Then only you can start plotting the graph. So Can someone tell me like why this is looking like this? Like, because we are using the right function here, we are using the right x-axis and y-axis. Why it is like this?
Could
Can you
be
guys tell me?
you use one column, just one column.
How does it make difference?
Because it's not clear if depends on the date. I mean, if the graph. Yeah.
Let's remove color. Let's remove the color, okay? And see what happens. See, it takes the default color, but the graph did not change. So here is the thing. When you work in the graph, scaling of data is really important. When you are going to create a graph, when you're going to do a prediction, you need to make sure that your data are scaled properly. Otherwise, like nothing will be right. Whether you are going to writing a predict function, that also will not be good. Whenever we are creating a graph, that also will not be great. So that way, what you have to do, you have to make sure that you need to have a meaningful data here. The reason why this graph is looking like it, because we have so many countries, and some of the countries have a very high number of death, and other countries does not have a decent number of death. So there is a huge difference in death. And because we have so much of the value in excess is like more than 200, and the gap in the death is like really high, that's why it is like showing such a messy graph. I mean, you cannot figure out anything, right? So how to deal with that? So you can either increase the size of the graph. You can either increase the size of the graph. That is one of the way. And you can provide the parameters over here, or you can break the data. You can break the data in a different way. So for example, we want to know only the countries where the number of deaths were more than 10,000. So maybe you will see better number over here. You want to, and you may want to scale the data in terms of thousands. So I'm sure you guys must have seen this kind of graph where it says like number is in thousands. That way you can scale the data. So scaling parameters sometimes comes in the picture. You can create different scales, and then we have to convert the data into that scale, and then you can draw the graph. That is one thing I want to show you. Also, I want to show you one more thing. I want to show you like how we draw the scatter plot. We'll fix this graph next class, next session. But let's move on to the scatter plot data. So this is one of the bar plot. There is something called scatter plot. Scatter plot is nothing but a graph which you prepare on based on the two numeric variables. So for example, let's take an example of number of visit to a grocery store and spend you make. So for example, if somebody is going to grocery store 5 times, he will spend more. And if somebody is basically going to grocery store less, he will spend less. So there's a direct correlation between how many times you're going to the grocery store and how much money you are spending. So there is a direct correlation. So you can create a scatter plot. Scatter plot gives you data on 2 different axes. And those 2 axes primarily are like numeric. You can have a dot plot with a numeric and categorical value, but scatter plot is primarily for 2 numeric variables. So let's plot scatter plot data and see how it is. So we'll use the death versus confirmed cases. So we'll try to understand what are the correlation between death and the number of cases. Is there any correlation between these two or not? So what we're going to do, we're going to just take X and Y. So what I have done here is, as you see here, we are doing bar plot. We just use bar. We are doing scatter plot. We're just writing scatter. And we're using the PLT. So that's That's simple and straightforward. And we are going to use cumulative cases to that. So let's use cumulative cases. So we have just cases number name here. So y here is sorry, cases. Okay. So that's thing, and we provide the name of the data frame. We'll say data is equal. So either you provide so as you see here, I am providing the name directly to the reference of data frame. You know, in this case, these are different methods, different ways actually to do the same thing in Python. As I said, every programmer has its own style here in Python or any language. So feel free to use your approach. There is nothing right or wrong approach here. Every approach here is correct, absolutely correct and valid, as long as it gives you the graph, you know? So let's create this. So see, as you see, the number of points which you see here in the scatter plot, something's, you know, straight line, I would say. Now, how we confirm that this is, we can do something like best plot fit. We can do best plot fit. Now, how we do that? Let me show you real. So remember, we basically imported Seaborn. We'll use Seaborn library also to show you one of the graph here. So Seaborn library is also really popular. So if you are focusing on exploration of data analysis using Python, I would recommend learn both Matplotlib and Seaborn. Both are great, but Seaborn has more flexibility and more, I would say, it gives you multiple options and very flexible in creating data exploration. So learn both. Most of the approach, most of the functions are pretty much the same here in Seaborn and Matplotlib. So we're going to create this LM plot. Okay, LM plot is nothing but a line plot. Basically, it is a line plot with the scatter plot mix. So we are going to use the exact same thing, but a different method. Okay, in the LM plot. Okay, let's see what happens. It gives a line. It gives a relation that there is a linearity in the data. When the number of cases goes high, the death also goes high. Make sense? So these are the basic graph you will focus in data analysis. One of the most important graph which you will focus in data analysis is time series graph. Time series graph is really important. And we do time series analysis very often. For example, if you have a data from the website where you have the number of orders every day, and you want to plot the number of orders every day in a graph, how do you do that, right? So if you look at the data from the WHO, what we have got, the data is not a time series data. Means there is no time frame mentioned here in this. Okay, so we cannot plot any time series data in this. So to plot a time series data or graph, we need to have a data frame or data which has a time. Either we convert some column into time, or that data has explicit time column. So let me show you one small example here. I remember that when we were sending the email earlier, we sent the data from Kaggle, correct? That Kaggle data set has the time series information. So let's take a quick look before we wrap up the session. Okay. All right. Oops. 1 second, I might be wrong in terms of the data frame name. Give me 1 second. Oops. Yeah, it should be data, not date. All right, so now here we have COVID-19 new. So this data has the observation date column. So using this column, we're going to create a time series graph. So there are different ways to look at it. Some people will create the time series graph by putting the observation data on an x-axis, you know, uh, and some people will basically change this observation data into index, you know, because that's the time is in index here, you know. So I'll talk about index in the next class, because index is really important when you're going to do the predictions and other things, and converting this column, especially date column, into index, uh, because time series, it gets, because when you are working with the time series data, you will have different graph requirement. Like you will try to create a 7 days moving average, a month moving average, quarter moving average, because businesses reports their data based on the quarterly report, and sometimes monthly report. So we try to create those moving average time series data, like graph. So we will look at the time series data maybe in the next class at the beginning, and then we'll move on the prediction analysis. I'm going to share this file, which I was working on, so that you guys can run the exact code and you can familiar yourself, so that it may help you in understanding it better. Any questions? I wanted to make sure that you guys have like clarity on what we are doing and what we want to do in future. Any questions? Okay,
Feel free
great,
to
great.
ask your questions over chat, or
Yeah, feel free to ask any questions.
feel free to
I'll,
unmute. That's okay.
yeah, yeah, totally fine with that. I hope you guys have enjoyed the session. Session was not too technical, was it? Anybody, any feedback?
That was wonderful. Thank you very much.
Okay.
Can you post a link to the prior sessions?
Yeah, I will
Yeah.
send the link. Plus, I have sent a feedback URL in the chat. There are 3 questions. Please provide your feedback. That will help us to improve our delivery and understand if this session was helpful. And I have also sent link where you can go and access the recordings of the previous webinars.
Thank you.
Yeah, so I think it was a great session, Abhishek. Very helpful, especially if someone is starting new with the Python. It was very important to know all these things and concepts. So thank you, Abhishek. Thank you for your time. We will connect, guys, again next Saturday. And Abhishek has some more interesting stuff to discuss again in the next week.
Yeah, just to let you know, next week we will discuss same COVID graph for the time series, and we will pick up a very popular company called Instacart, maybe, to understand the prediction. Because next week we will talk about like the prediction. We'll start with the prediction, and we will start with some of the basic concepts. What are the steps required to think about what you're predicting and how you're predicting, and the approaches. And then we'll get into the popular methods and approaches and algorithms. So I'm not going to explain the algorithms 100%, but I will point you out to the best resources, so that if you need to read more about how that algorithm works or how this algorithm works, probably you should be able to understand those very clearly.
Perfect. Sounds like a good plan. So, guys, don't forget to connect again next Saturday.
Yeah.
We have some interesting stuff to discuss. Till that time, take care.
Awesome. Thanks, everyone. Have a good day. Good night.
All right, thank you so much. Have a good night.
Thank you.
Thank you, guys.
Thank you.
Thank you.